Hello, Chem students. Today's note will be for the start of chapter 11. Sorry I can't be in class just to be safe, but hopefully everything will go well. And with that, let's begin. So the word Stoic Geometry just basically means a study of proportion or ratio of material. In this case, reactant that goes in compared to product that goes out. And the word that we're going to use to compare chemical in chemical reaction from chapter 10 is going to be mole. So often it's just a ratio of mole that goes in and out, or that goes out and in, or even in compared to in for another reactant. So it's just a ratio of different material, that's all. And everything will go through the mole, but of course we will convert it to liter, gram, or molecule, because those are real life measurement. Okay, once again, before you do any calculation, you need to have a balanced equation. So if you forgot how to balance equation, make sure you review that. Also, some of the questions on the test will require you to write the equation on your own, so make sure remember to write chemical formula based on the name. So if you're given a name, you're able to write the chemical formula correctly. Okay, so everything will go through the mole at least one time. Some of this bracket will have mole one time, some bracket will have mole twice. The bracket that has mole to mole is called the mole ratio, and it's just a comparison of the coefficient in a balanced chemical equation. So it's just a ratio or comparison or fraction of the whole number coefficient found in the chemical equation that is already balanced. So let's do some, okay? So once again, the mole ratio is just the coefficient ratio in the balanced equation. So I have an equation here. I have HF, which is an acid. And with that, I'm going to dissolve some aluminum into it. This is a single replacement because Al is an element, HF is a compound. One element, one compound. Remember, the left side of the periodic table replace the left side. So aluminum is the left side of the staircase. It'll replace hydrogen, which is on the left side of the staircase. From this, I'm going to get AlF3, because Al is 3 plus, F is 1 minus. That's how I get AlF3, just in case you don't know. Plus, hydrogen gets kicked out, but because hydrogen is a gas, it will have a 2 in the bottom. So that is a chemical equation, but it's not balanced yet because you can clearly see the number of F on the left and the number of F on the right are not the same. So let's take a second to balance the equation. I see I have 3F, I have 1F, they're both odd number. And obviously I have 1H on the left and 2H on the right, so I need to turn the left into some kind of even number. So I'm thinking that like if I put a 2 there, I will have 2F. That's not going to balance out with the right. If I have a 4 there, 4 is not a multiple of 3. So let me put a 6 here, because 6 is a multiple of 3. When I do that, I have 6H, so I put a 3 here. But that also gives me 6F on the left, so I put a 2 here. When I do that, I have 2Al on the right, so I put a 2 there. And now we have a balanced chemical equation. So what is the mole ratio of hydrogen to aluminum in this case? So we're going to be looking at this and this. So the ratio of Al, dot dot means ratio, to hydrogen 2 is what? Number below Al is 2, and the number below H2 is 3. Another way to say this is the ratio of hydrogen 2 to aluminum, because it doesn't matter the order that you put it, is once again 3, 2, 2. So it's just a comparison of the coefficient in the balanced chemical equation. So pretend we have a question, but first we need to have that equation that we have on the last slide. So it'll be 6HF from my memory plus 2Al comes out to be 2 aluminum fluoride plus 3 hydrogen gas. Okay. So from that, let's do this question. If I have 5 mole of aluminum, so I'm starting out here, how many mole of hydrogen gas do I have? And I'm going to finish there. So follow our procedure, 5.00 mole. But now we need to list what chemical it is, because we're comparing one substance to another. It's not the same substance. So we have to label information. So 5 mole of Al, one bracket at a time. I put mole of Al in the bottom because that's what we start with. And now, can I go from mole of Al to mole of hydrogen? So the rule is whatever you have in a bracket, you only can change one thing in a bracket. So looking at this, I have both unit being mole, so there's no change there, but I'm changing from aluminum to hydrogen. So I am following the rule where I'm only using one change per bracket. So the number in front of hydrogen is a 3, and the number in front of Al is a 2. Cross that out. Have I reached my goal? And my goal once again is mole of hydrogen. So I have reached my goal. I am done. I punch it out. 5 times 3 divided by 2. What is that equal to? And the answer on my calculator is 7.5. And the unit is mole of hydrogen gas. So that'll be the easiest question for chapter 11 is one bracket. And it's going to be a mole to mole ratio. Let's do a little bit harder one. So how many liters of CO2 will be produced if 18 mole butane was burnt? So first I have to predict the product. Butane burned, this is a combustion reaction. And the product of combustion is always H2O and CO2, or vice versa, it doesn't matter. I have 4C, I have 8H. Now I count 4 times 1 is 4, 4 times 2 is 8, 8 plus 4 is 12. So I have 12O. Balance equation. Okay, so following the rule again, write what you are given. And butane in this case is C4H8, roughly. Should be C4H10, but no biggie, right? So do a conversion bracket. Mole of C4H8 goes in the bottom. And what am I going to? I'm going to liter of CO2. If I were to put that in, I'm going from mole to liter, and I'm going from C4H8 to CO2. That's 2 change. So I'm not allowed to do that. So what can I possibly go to closer to CO2, but it's only 1 change? So I can try to go to mole of CO2. That is following the rule. So the number in front of C4H8 is 1, because I don't see anything in front of it. The number in front of CO2 is the 4. I cross that out. I haven't reached my goal yet because my goal is liter of CO2. So I do another bracket, and I will keep on doing it, following the rule that I only can have 1 change per bracket to get to what unit I'm trying to find. So let's try to put down mole CO2 here because it's on the top of the last bracket. And now let's ask yourself, can I go to liter of CO2? Is that 1 change? So CO2 is staying the same, but mole going to liter is 1 change. So whenever you go from mole to mole, you use a mole ratio. But whenever you go from mole to liter, mole to gram, or mole to molecule, you follow the same rule that we're doing right now in chapter 10, which is the number in front of mole will always be 1 when it's opposite to a different unit. So it's always going to be 1 mole when it's opposite to liter, gram, or molecule. The only time it's not 1 is when it's going from mole to mole. And that's the only time you use the coefficient. So that is all that is new for chapter 11 is whenever you go from mole to mole, you use the whole number in front of the coefficient. Everything else is exactly the same as chapter 10. So the number in front of liter for gases is 22.4. Cancel out my unit. I do have the unit I'm looking for, which is liter of CO2. And I just punch it out. So I grab my calculator. I go 18 times 4 times 22.4. And the answer is 1,612.8 liter roughly. So you can see we make a lot of exhaust gas when we burn fuel. Here, let's try that equation again. So once again, we are burning butane, but instead of going to liter, we're going to go to molecule water. We started out with 18 liter of butane. In this case, it should be butene, but I apologize for that typo. So once again, we have C4H8 plus 6O2 leads to 4CO2 and 4H2O. From the last slide, we have that equation. So once again, follow our procedure. Start with what you're given. Do a conversion bracket. Whatever unit you start with goes in the bottom. And my question is, can I go from mole of C4H8 to molecule of water. So if I'm changing from mole to molecule, that's one change. If I'm changing from butene to water, that's two change. So I'm not allowed to do that. So I can at least try to go to mole of water, which is H2O. So whenever you see mole in the bottom on the first bracket for this chapter, it is most likely going to go mole to mole. Okay? So you see mole in the bottom, it's most likely going to go mole to mole. Not guaranteed, just most likely. So the number in front of H2O, again, is a 4. And the number in front of C4H is nothing, which is 1. So I cross it out. Have I reached my goal? Have I have molecule of water? Mole is not the same thing as a molecule, so I do another bracket. So I put mole of H2O in the bottom. And now, can I go to molecule, which we abbreviate by MC, of H2O. So I look at it, H2O is still staying the same, so no change there. But I'm changing from mole to molecule with just one change. So we're following the rule, you're allowed to do one change per bracket. And the number in front of mole, always when it's opposite to a different unit, is 1. So mole to molecule, mole to gram, mole to liter, always 1 in front of mole. And the number in front of molecule always is 6.022 times 10 to the 23rd. So be very careful punching this out again, because some of you are not using the double E button. So I go 18 times 4 times 6.022, double E button, 23, and I hit enter. And they gave me a pretty long number, but I'm just going to round it off to 4.336 times 10 to the 25th. And the unit is molecule. And the chemical in this case now is water. So here we don't just have the unit, but we have the identity of the chemical because we're converting it from one thing to another. So that's an example of a 2-bracket equation. Okay, one last one. So once again, our equation is C4H8 plus 6O2 makes 4H2O plus 4CO2. Okay, so just underline what you're given and box what you're trying to find. So here we're going liter to liter. So this one is going to be more than 2 bracket, and you'll see why in a little bit. But just trust the system, one change at a time, okay? 44.8 liter of CO2, bracket. Unit that you start with goes in the bottom. Every bracket needs mole at least one time. I don't see mole yet, so it's going to be mole. But mole what? I'm already changing from liter to mole. So I am using up my one change. I have to keep the chemical the same. So it stays as CO2. The number in front of mole is always 1 when it's opposite to liter or gram or molecule. And the number in front of liter is 22.4. Cross out my unit. I'm not even close to liter of oxygen, so let me put another bracket up. If I started with more of CO2 and I don't want it, I'm going to put it in the bottom. And now, if I go to more of oxygen, at least it get me closer to oxygen, and it's following the rule of one change. Also, if you think you need more than 2 bracket, which you see on the trick slide at the end, the middle bracket will be mole to mole. Just make sure you know that. If you need more than 2 bracket, the middle bracket will be mole to mole. And here I'm going to oxygen, so I put in O2. So the top one will most likely be the chemical that you're going to. And the number in front of oxygen is a 6. And the number in front of CO2 is a 4. Cross out my unit. Have I reached my goal? No. Because my goal is liter of oxygen. So I do one more bracket. I put mole of O2 here. And ask yourself, can I go to liter of O2? So double check. I'm going from mole to liter. That's one change. O2 staying the same with O2. I'm following the rule. One change. I'm good. So once again, the number in front of mole is always 1 when it's opposite to liter or gram. And here I have 22.4 in front of liter. The nice thing about this is the 22.4 on top also cancel out the bottom. So I have one less thing to punch out. So always remember to cancel out things if you can. So the only unit I have left is liter of O2. And now I just go 44.8 times 6 on the top, divided by 4 on the bottom. And I'm done because the 22.4 cancel out with each other already. So I have 67.2 liter of O2 is the answer for this one. So here's your homework for today, since I won't be there to give you the homework packet. But write and balance an equation for aluminum oxide, okay, that was created from aluminum and oxygen gas. So I'm just going to give you the basic foundation, balance it on your own. So aluminum plus oxygen gas makes aluminum oxide, which is Al and O. Al is 3 plus, O is 2 minus. It becomes Al2O3. So please take the time to balance that. Okay. Second one is now you're going to use that equation. So once you have it done, just write it somewhere right here so you see the balance equation. And you're going to go from mole of aluminum to trying to find how many mole of oxygen. So if it's mole to mole, it's going to be one bracket. So this one is simply a one bracket equation. Here we're going from mole of aluminum. Once again, write your balance equation here so that way you can see it. And you're going to go to gram of aluminum oxide. So once again, just like in chapter 10, if you see the word gram, you first have to find the mass of that substance. So aluminum oxide is Al2O3. So please find the mass of this by adding up 2 aluminum and 3 oxygen on the periodic table. And you're going to put this mass inside the bracket. So here we're going from mole to gram. It's going to be 2 bracket. Okay. So please write this down in your notebook somewhere. This will be your best friend for this chapter. Most teachers won't have this slide, so this is just me passing on the experience to you. If it's mole to mole, it's going to be 1 bracket. Mole to anything or anything to mole will be 2 bracket. And anything else to anything else will most likely be 3 bracket, with the rare exception when we have to go from like milligram to gram or milliliter to liter, then you might have 4. But other than that, just the base unit, it'll be 3 bracket if it's any unit to any unit. So from liter to gram or from molecule to gram, it'll be 3 bracket. So with that, have a good day, and I hope to see y'all back soon on Tuesday. I'll have another note up on Monday for y'all. Have a good weekend.